Okay, so we're gonna go ahead and now solve this problem. Now, a container of gas is initially, so that's how it starts. So that would be one of the, of course, a ones. So it initially adds 0.500 atm. So this is atmospheric pressure, atm. So that means that is your P1, and it's at 30 degrees Celsius. So that's what the trick is you basically have to make sure you put this calculation, this formula as well. So we're gonna have to convert that to kelvins. So all you have to do, remember, you just put the 30 degrees Celsius plus 273. So I'm gonna add that 30 plus 273 equals to 303 kelvins. So I'm going to go ahead and put 303 kelvins, and that will be my temperature 1. Okay, that will be my temperature 1. Okay, so, and I'm going to go ahead and let me see if I can make it. Yeah, that's well. Okay, so what will be the pressure? So obviously this is P1, then this is afterwards. So because it changed from here to here. So it will be P2. Okay, so that's a one, that is your unknown. That's the one we're trying to solve. So that's the one we're going to isolate. Okay, so in here it's at 125 degrees Celsius. Oh, so that really increased it, right? So so we do need to, now this is degrees Celsius, so we do need to put 125 plus the 273 just so we could have this in kelvins. So let's add that. 125 plus 273 equals to 398 kelvins, and this will basically be your T2. Okay, so now we already know which is our variables. Okay, the number, the amounts are variables. So we're gonna go ahead and plug them in. So P1 is 0.500 atm divided by T1, which is 303 Kelvin, which is equal to P2, which is just a variable, divided by the T2, which is 398 Kelvin. Okay. So even if you were solving for P1 or T1 or T2, always do the cross multiply, because it's so much easier, the rules, when you just cross multiply, because after that, to move them around, you just have to divide. Okay, you don't have to do any other steps. So I do want to keep it simple. So again, cross multiply is your best bet on this one. Okay, so now we're gonna go ahead and put 0.500. Okay, and then you're multiplying it by 398 Kelvin, and then you're gonna put the equal sign. Okay, and that will be your P2 times your 303 Kelvin. Okay, so once you do that, remember you want to isolate. So again, even if it's your P1, say for example you're trying to solve for your P1, then you will move the 398. Okay, and if it was the T1, then you will move that 0.500. Yeah, I mean, as long as you're moving the number to the other side, it's the same steps. Okay, so on this one, this is where I want to solve. The variable I want to solve is the P2. So this is the number that I need to move with the other numbers. Okay, and since we're multiplying, you do the opposite division, which is and of course we're gonna put 303 Kelvin. Why? Because that's the one I want to move. And then you do the same thing to the other side of the equal sign. Okay. Okay, so once you're done with that, you can cancel 303 Kelvin. Because if you think about it, 303 divided by 3, it's just 1 anyway. So, yeah, cancel it. And then in your review, you should have the P2, and you should have the exact setups. This is your pressure. That is the temperature. And that will be your temperature 1. This is the actual temperature 2. Okay, so anyways, again, it should be set up exactly like that in your review. Okay, so now we're ready to multiply the top. So it would be P2 equals, okay, so let's calculate. Okay, so it's 0.500 times 390. It's 199. And of course, that's ATM times Kelvin. Okay, and then again, I'm just multiplying these two, and then I put the division right here, this line. So once I multiply, and then you divide it by 303 Kelvin. Okay, so I am running out of space. So, okay, so now here, these cancel. Okay, and now we're ready to divide. So it'll be 199 divided by 303. That should give me, now it says here 0.65. You see that? But next to the 65, the 5, it's a 6. So it's more than 5. So I got to round it. I got to round that one to 0.66. You always go up 1 if the number next to it is more than 5. Okay, so it's 0.66. And that will be ATM because those cancel. And anyways, if you think about it, pressure, atmosphere, right? That should be the units for pressure. Okay, so that's your answer, you guys. Okay.